As we go on to topic 4.1, radical expressions, functions, and models, I'm going to change the format a little bit. You're going to look over the learning objectives, and we'll jump right into the examples. And I will give you background as needed, and we'll set these up with a little more room to write over here. So we have here the square root of 49, then the square root of 9 over 100, then the negative square root of 16, and then the square root of 0.004. So they want us to simplify, and what two numbers will give us a 49? What times what that are the same number? And the answer is 7. And we're looking here for the what is called the principal square root, because we know a negative 7 times a negative 7 would give you a 49. And here the square root of 9 is 3, and the square root of 100 is 10. Now for this one we have the square root of 16, but then we apply the negative sign, so we can do that first, and this will be a 4. Now here we need to have, do I have enough decimal places there? No, I need one more 0 actually. There we go. I needed 3 there. So 4 decimal places. So that will be 0.02. All right, so these were relatively easy. And what we want to do in the next few is, again, copy these down over on the left, and I'll do that here as well. So for these, it's a matter of substituting our value that they're giving for x, which is a 7, so this will be 35 plus 1, so this is going to be a 36, and the square root of 36 is 6. And here we're going to put a 20 there, so this is 4 times 20 is 80 minus 3 under the radical sign. So this becomes a negative square root of 77. So again, nothing too difficult yet. Let's continue. So let me write these out here as well. Now for these, we want to simplify each expression. Assume that the variable, now it's just the variable, can represent any real number. So when we take the square root of 81, we know that it's an 81, and the principal square root of 81 is 9. Now when we take the square root of z, and keep in mind that in our next section we're going to indicate that there's an index number there that we don't write when it's a 2. But if we take that 2 and divide it, we get z. But that z could have been a negative value. So to indicate that, we then put absolute signs by the z. 81, we know its principal square root would be a 9. The z we are uncertain of, so we put absolute value. Now, recognizing this is actually a perfect square trinomial that will factor into y minus 3, the quantity squared. So when we take the square root of this, and again our 2 is there, divided by 2, we get y minus 3. But again, this value could have been theoretically negative. So to ensure that we get all the values, we put an absolute sign there. Again, there's a 2 there that we're going to divide the 12 by 2, and we get x to the 6th. Now, we don't put absolute value there. All right, let's go on. For each function, find the indicated function value. So we're just going to do some substitution in some cases or simplification in others. So let me write these out. So what we're going to do here is take our 32. 2 times 32 gives us a 64. And 64 is a perfect cube, so the cube root of 64 is 4. Now, that basically is the answer, and you don't have to use any absolute signs or anything. Now here, our g value is going to be a negative 128. So this is a negative 128 plus 3 gives us a cube root of a negative 125. Well, 125 is a perfect cube. That's 5. And if you have an odd index number here, a negative sign under the radical is perfectly fine. So this becomes then a negative 5. Because negative 5 times negative 5 is a positive 25. Times a negative 5 is a negative 125. So again, it's the third root of a perfect cube. So this will become a negative 3, following the same pattern. And then if we take the 3, our index number, and 6 divided by 3, we get x to the 2nd power. And those will check out. All right, let's continue. We're going on to simplify each expression. Assume that any variable can represent any real number. So here we need to use, if needed, absolute value signs. So let's raise it up our last bit and write these out. First. Now, since this is an odd index number, a negative under the radical is fine. And that happens to be a negative 3. If you take a negative 3 and raise it to the 5th power, you get this. Now, 4, the 4th root of 81 happens to be 3. And your x to the 4th, again, taking this 4, dividing it into the 4, leaves you with an x. But that could have been a negative value, so we have to put the absolute sign there. Now, this will be a negative from this negative sign out there. This 6 divided by this 6 is a 1, so it just becomes x minus 5. But again, that variable could have been a negative value, So to ensure we get all our answers, we put the absolute value sign there. And looking at this one here, this is an odd index number. So 9 divided by 9 just gives us an A. We don't need an absolute sign because odd numbers can be negative. Okay, let's do our last few. So once again, the index number is 7. It's raised to the 7th power. So we can take that index number, and 7 divided by the index number makes this a 1. And since it's odd, we don't need to put the absolute sign. Now here, this is an even index number. We don't have any value for an index number when it's even if under the radical sign there is a negative. So for something like this, there is no value. So we say it's not a real number. So if you had like the square root of 2, of a negative 2, I should say, there would be no numbers that you could multiply together and get a negative 2. By multiplying, it has to be the same sign. So that's not a real number. The same way the square root of a negative 4 is not a real number. So the possibilities, you might say, would be negative 2 times negative 2. But that gives you a positive 4, as does a positive times a positive gives you a positive. So there's no way to multiply two numbers, two real numbers, and get a negative 4, that these real numbers are the same. That's why in this case, an even number index number and a negative sign under the radical, it's not a real number. Okay, in example 5, they're asked to determine the domain of each function. Well, domains are x values, and we want to see whether there's any restrictions. Well, we know under a square root sign, we can't have anything that would make this less than 0. So here the index number is even, and since whatever value we have of x is going to be squared, so any negative number squared is positive, so you will always end up with positive numbers under this radical sign. So x has no restrictions. So it's from negative infinity to positive infinity. That would be interval notation. Notice infinity is with a parenthesis, and negative infinity comes first. Now, for this one, and this is an equal sign here. These are equal signs. Here, this is square root, so we can't have a negative number under the radical. So this radicand, which is under the radical sign, has to be greater or equal to 0. So this value under the radical sign has to be greater or equal to 0. So when we solve this, x is going to be greater or equal to 5. We just move that over. So what is this in interval notation? Well, again, since we have the inequality and an equal, we're going to use a bracket to indicate that 5 is in the set. And it's going to start with 5. And it goes up to infinity. So that is the solution for this. Now, since this is an even index number, the same thing applies. We have to have values of x that make this greater or equal to 0. So we just solve it. We get 15 is greater or equal, just transpose that. On the other side, it becomes a positive 2x. But let's write it this way so you don't get confused. 2x is less than or equal to 15. I'm just changing the direction. Remember, the point is toward the 2. Now we divide both sides by 2, and we get then x is less than or equal to 15 halves. Now, how do I put that in interval notation? Well, remember, x is way over there, coming from negative infinity, going up to, and it includes 15 halves, and we use a bracket. So these are our values for the domain of each of the functions. These are x values. And again, if you have any question, be sure you're asking it. Now, for this last one, we have a statement here. The profit of Bill's sign shop can be noted by this function. Function of x. Oh, in this case, they want us to use a t. So let's use a t then. P, function of t, is equal to 34, the square root of x. Where P is the profit in thousands of dollars, and T is the number of years. Okay, so from 2000 to 2015, how many years would that be? And the answer is 15. So you put this in your calculator, and be sure you know how to put that in the calculator correctly. Multiply it by 34, and the answer comes out 131, comma 681. Now there's some cents there, but they want it in dollars apparently. So that is your answer. And this will wrap up this first lesson in our new format.